Okay, this is Co6, and it says, suppose you have a friend who wants to go bungee jumping for her birthday. She wants to jump off a high bridge over a river and be able to touch the water below right when she gets to the bottom of the bungee cord extension. You want to double check all the physics of the bungee jump to make sure it is safe for her to go jumping. Identify a few things that you would like to know about the bungee jump, then making reasonable assumptions for some of the properties of the system. Determine what needs to be true so she has her birthday wish. Okay, so I listed what I want to know. So mass of the rope and my friend, change in x, which is the change in the length of the spring, and velocity final. And what we do know is gravity equals 9.8, velocity initial is 0 meters per second, and y final is 0 meters. So I made the water y final. So what I did was start with the sum of the energies. And so the sum of the energy initial plus work exterior equals sum of the energies final. When you put all that out, you have potential energy of the spring plus kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final plus potential energy of the spring again. Well, there is no potential energy spring because there is no stretch at the beginning, and there's no kinetic energy initial because the girl's not moving. So what we're left with is UGI equals KE final plus UG plus US. So when you break that down, you're going to have MGYI equals 1/2 MVF squared plus MGY final plus 1/2 K delta X squared. And now I'm going to make the assumptions. So I made the assumption that the mass of the rope and my friend is 60 kilograms. So my friend is about 58 kilograms and the rope is about 2 kilograms. Y initial, which is the top of the bridge because I made Y final the water, is 227 meters. Gravity is 9.8. Do not know the spring constant. Change in x is 1/4 of yi. And when you do 1/4 of 227 meters, you're left with 57.75 meters. Velocity final, I'm going to assume is 0 because you're not moving at that stopped instant. So when you plug everything into this equation up here, this is what it's going to look like. And the only variable we do not know is k. So we're going to solve for k. And once you do, k equals 82.89 Newton meters, which makes sense for the situation of my friend bungee jumping. So therefore, she will be able to go bungee jumping for her birthday because it will be safe.